Hello, everybody. Hey, I got all this lighting out, so I could uh, figure out what it is I bought. I've had this for probably a year. I thought since I've got all this out, I'd kind of show you what I'm using here to light my buildings and stuff. And there's a lot of different ways you can do this. This was just something that I ran across. It This is an eBay seller. I got both of these components. This is the self-adaptive power supply for the LED lighting that I was talking about. The company is called Eve Model, and there's another company that's very similar to these. I mean, they claim they're out of California, but there's another company called We Honest, and they're from China. And I know this stuff is all from China too, but I'm not so sure it's not the same company, but they sure come from different places when you buy it. And I was surprised. I did buy some cross-section signals to use here on my city scene here to control or to utilize them. And I bought those from We Honest, and I was kind of surprised how quickly they got here. I think it took like 5 days from China, so that was kind of hard to believe. So it makes me think they're selling from here in the United States somewhere, and it may be this Eve Model because they have very similar and sometimes identical stuff. I think We Honest might have a little bit different stuff. If you want some of the specialty LEDs, like gooseneck lights, pendant lights, street lighting, they tend to have maybe a little bit more selection on that. But for now, I'm just trying to refresh my memory here. And when I bought these, I'd said in an earlier video, LEDs when you buy them without resistors are 3 volts. They're 3 volts DC. So these work off of DC, and these were rated. You can see on the back here, it says DC 12 to 18 volts, 20 milliamp, Eve Model. And so these will work on a range of 12 to 18 volts. Now, and it says DC, but their instructions, there's not really a whole lot of instructions that come with these. You have to kind of use their description. When you go to buy them online, in the description, it's got instructions in there. That's where you find out how to wire them. And We Honest is the same way. These were something that when I seen them, I mean, these are what they would call an SMD, which is a surface mount LED. These are on a board like that. Your SMDs are like that. They're not an encapsulated LED. I use SMDs for my buildings. You don't have to use these for your buildings, but these are designed to spread light radial in all directions. Encapsulated LEDs, they're great for your headlights for your trains and stuff, but they're more like a flood bulb. So they're really kind of directional. All the beam is kind of focused in one direction on those. And so if you want to kick the light around and spread it and have more spread inside your buildings, SMDs are the way to go. You don't have to use these. There's a lot of different manufacturers out there. Now this little package of lights, I think with shipping was $10. And there's 20 of them on there. They're individually segmented. You can break them off. They're made to break off so you can put them individually in the building. There's 20 on this board. This little component here, which is their self-adaptive power supply, was about $15 of shipping. I mean, their shipping's like $2 or something. So I think this was $13.99. So you're going to have some shipping and some tax on there, but around $15 for this little board, which I thought was, worth taking a chance on. I don't know how good any of this stuff is. It's all from China. You don't know how long any of this is going to last. But what's neat about this little board, I probably didn't need it necessarily because since these are rated 12 to 18 volt, you'll see here they've got the resistor just below the LED. That little component you see just below there, that's a resistor. So these have a resistor that enables you to power these on a 12 to 18 volt. It's a 12 to 18 volt, so anything in between there. So, if you do a variable transformer like what I've got, is, unless you just use your fixed voltage, CW80 is a good one to use because you can dial in your fixed voltage on that to whatever you want. Anything from whatever its minimum all the way up to its maximum and everything in between. And I'll probably, feed these maybe from a CW80. Actually, it won't really matter because this little board, what's neat about this little board here, that's another reason why I went to get the little board. You couldn't recall. I remember seeing the instructions are saying you've got 28 terminals. You got 1, 2, 3, 4, 6 JST connectors, and they give you all the connectors too, by the way. You got JST connectors or these screw terminals or these little special pins that just plug into these. You got so many of those. Each one's a pair. So there's enough to do 28 individual LEDs. Well, I think what the deal is on this, I'm trying to prove a theory here. It's what I'm doing. I think what the deal is with these, if you use the 3 volt LEDs, you don't need resistors. That's what's neat about this board. So if you use the 3 volt LEDs, you don't need any resistors because this little switch down here, this is a selector switch. This would be on your DC side of this board, which would be all your lighting. So this has a setting on here. You can set it to 3 volts, 12 volts, or direct. And direct is just whatever I'm feeding it with my transformer, whatever voltage that is, that's what's going to come out. So in this case, let's just say it's 10 volts. Well, if I use 10 volts, it probably isn't going to work because my LEDs that I bought, SMDs that I bought, are rated 12 to 18. So that means I would have to use something between 12 to 18 volts at least to feed this board for a direct. So the neat thing about this board too is it gives you 1, 2, 3 different ways that you can supply your AC line voltage to this board, or DC, because this board is rated 4 volts to 24 volts AC or DC on this side of the board. So whatever my input is in here, so this would be input terminals. In this case, I'm going to run in here 12 volts off of my little 1033 you see down here. That 1033 is what I'm going to use to power this board right now, just for demonstration purposes. And so I'm going to pump in here 12 volts. And the way I've got a set up for a fixed setting. The way I know what the voltage is, I'm using a meter. And then I'm also not taking a chance of using the variable voltage on this transformer. So I have a toggle switch I use for my turnouts and control track sections, that type of thing, and my isolated rail. So I'm just using one of these toggle switches where I can just turn this board on and off. So I've got power coming from this transformer. Just so you can see here, I've got power coming from this. It's pretty haphazard looking, but I've got power that's coming from the transformer, and it's running off of this hot wire right here to my switches, and I've got them all daisy chained, and I got the switch leg loop coming back off, and it's going to the wire, one of the 2 wires on this board. The common is just tied directly to the common terminal on my transformer. So that's the setup here. So this will let me select this and set it even at fixed voltage, because the fixed voltage on this, it's like 16 volts, and I didn't want to pump that much in there. I could, because the SMDs are rated for that, but I'm going to go down to the 12 volt. I want to try to maintain 12 volts. So that's why I'm using the variable voltage. I'm just making it so that the transformer's on right now, but I've got it shut off. I've got the board shut off over here. If I flip this on, that board should come on, and then the SMD should come on. So what I'm trying to prove here is I can wire more than one LED off of one of those terminals. And it's because those boards have resistors in them. If they were 3 volts, I wouldn't be able to do this. So that's all I'm doing here. And why I'm trying to figure this out is how many wires I need to run to each one of my structures. That means I could probably just run one feeder over there. And, because I want to put this board in this control cabinet, because it's just going to be a better spot to put it for servicing, and then also to add lights in buildings wherever I need around the layout. So this would be like a central location that I could just string wiring from to feed other buildings, lighting, and that type of thing. Now, the neat thing about this board is that since it's rated on the line side, as an electrician, we're going to talk to you about line side and load side. Your line side is what's coming off, in this case, a transformer, your circuit breaker. Your load side would be, after that connection, what's actually drawing the load. In this case, it'd be the lighting. So this would be line, this would be load in this case, because this is the load of my lights, this is the line supply. So this little board lets you run 4 to 24 volts AC or DC power into this board. And what it's going to come out as, it's going to come out what the lights can use. And that's why I'm using this board, even though the instruction says those are 12 to 18 volts AC DC. When I seen that DC on the back of there, yeah, they may work off of AC because they're a diode, and the nature of a diode is to just have the voltage go in one direction only, which is forward. And so that probably work off of AC, but I don't know that that's the best thing to do. So that's why I'm using the board, because I know off of this side it's going to be DC. And that's why I'm maintaining it. I want this to have a DC supply. And then the other thing I don't know is there's nothing to tell me what the maximum load of each terminal can handle. This is this connection here. This actually, will work right off of. This is a Menards wall wart that they use for the little Christmas lights to light their buildings or whatever. And you could use this wall wart in place of the AC power I'm using off my Lionel 1033 transformer, because it's 4.5 volts. And this is 4 to 24 volts AC or DC. So I could use that. Now this little wall wart, it's only, it's going to have an input voltage, which is going to be 120. You can see on there, it's going to tell you 120, just kind of like this. What's coming out of this. So this is transforming your 120, goes through here, just coming out 4.5 volts DC. So this is actually transforming your wall power from AC to DC. Just like what that board's doing. Same thing. So I could use this to feed that. Now, the capacity on this is, as far as your amp draw, is nowhere near the capacity of a 90 watt AC transformer. This thing's only 1 amp. Now, you ask yourself, well, how would you know how big a transformer you need? Well, we're going to use a little bit of Ohm's law here. It applies to this as well. And I explained to you that LEDs typically are factored at 3 volts. So if we use Ohm law and we know the load of an LED is 20 milliamp, that translates into, at 3 volts, 0.05 watts. Now, how do we find the amperage? And why do we need to know amperage, and why do we need to know wattage? Well, wattage is what the manufacturer usually lists the light source in. The amperage is what the manufacturers that make the transformers and the circuit breakers, that's how they rate theirs. So you know the maximum amp capacity that it will handle. So you have to apply those to know what size transformer, what size circuit breaker you need. And it's pretty simple math. If you know the voltage and the watts are known, you just divide the voltage into the watts. So in this case, you would divide 3 volts into 0.05 watts, which is 1 LED. Now, this thing will do 28. So if I took 0.05 and multiplied that times 28, you should get 1.40. 1.40 watt. Well, that's 1.40 watts because we know 1 LED is 0.05 watts. So how do we know how many amps that is? Well, we just divide. In this case, you could divide 3. Even if you divide 3 volts into that 1.4, you're not going to get anywhere close to an amp. So that's just how many LEDs you can run off of that little wall wart. So you would be fine running that. We can do the math here real quick. So I'm going to take 0.05. It's kind of hard to do this one hand. And they're going to multiply that times 28. That's going to equal 1.40. Right there it is. Now I'm going to divide that by 3 volts. 0.46. So 0.46 of an amp. It's just under a half an amp. This formula works for any electrical circuit you're trying to figure out. Now, if the volts are known and the amps are known and you need to know the watts, well, guess what? You just multiply that. So you'd multiply 3 times 0.46. Now, since this is got these resistors in there, it's actually allowing me to run those lamps off of 12 to 18 volts. So if I took that 1.4 total watt load and then we divide that by 12 volts instead of 3, 0.11. So you can see that see how that comes up, 0.11. So the higher the voltage, allowable, permissible voltage. In this case, I'm allowed to use 12 to 18. You can't just run a 3 volt one at 12 to 18. It has to be designed to do that. So if you are allowed to do that, you'd want to try to use the maximum allowable voltage because it's going to drop your amp load. I hope this all makes sense so that you kind of know what you're up against when you're doing this. But I'm trying to test a theory here, and I'm willing to risk everything just to see if this works. So when I flip this switch on, I'm hoping, since I've got all these LEDs paralleled on one individual feeder, that's going to let me know I can put more than one LED per terminal. So here we go. There's the indicator light on that, and the LEDs are working. So all three of those are working. Now, this little power supply right there, if you see that blue fitting, that's actually a little dimmer. So it actually has a dimmer built into this board. So if your lighting is too bright, you can tweak that a little bit and make it brighter or dimmer. So that's another nice feature about the little board. That board's probably cheap enough. You could probably put one in every one of your buildings. And then just run right from your train transformer. What this gives you the ability to do is just run right off of your train transformers to feed your LED lighting. You don't have to have a special little wall wart or and a way to plug that in. You just simply run power. And that was, to me, the big advantage of doing the power supply. And since this thing is rated 4, it's kind of crazy, 4 to 24 volts AC or DC, you have a lot of options. Now, the 3 methods I was talking to you about that let you feed this board is that right there. I'm not sure what you call that. It's what, I can tell you, it's what Menards uses on there. So you could use that, or you just can direct wire it. You got 2 screw terminals here. Now, this little terminal here you see on the side, that one says one's input, one's output. What this does, this lets you simply, and they give you the little jumper wire here for that. This lets you plug in here and then feed another board, an add-on board. You can just keep adding more boards. So if you have more than 28 lights, in my case, I'm going to put more than one light. These are so cheap, I don't care. I mean, the problem I have is I don't have a maximum rating for one individual turner, how much I can put on one terminal. That's why I'm going to run each building a separate feed to each of the buildings that I'm going to add lighting in, instead of just running one feeder to feed it all. And that way I can make adjustments back here at the board. What this is doing, this is trying to help me figure out how many wires I need to run across here. And that's what this was all about. And like I said, it was so long ago since I bought this that I didn't really remember what I'd actually bought, even though I knew at the time when I bought it, it was going to fit the bill, just reading it. But you can see here, to test this transformer, it's on right now. See what I got here for voltage. Right now, I have this selector switch on the DC side of this set to direct. So it's showing me 12.62 volts. So that's what I'm pumping into here right now. And that's why I decided to use, to control that. So I could actually leave, do the permanent wiring this way too. If you hook this to your transformer, all you have to do is wire it to like a single pole bat handle toggle switch, and then you can control it with a switch. You can shut them down manually. So that'd be the advantage of doing a switch. In fact, this little board has there's a jumper right there that they put in that you can actually, I don't know if they have that lead in there, or you have to buy the switch separate. They have a little switch, toggle switch that you can buy. I think it's like more like a little slider, but it's a little switch that you could buy to put in your cabinet here and control the board that way too. But to me, I don't think I'm hurting anything, just interrupting the feed to the line side of this board. So since I had this out, I thought this might be good to show you guys. And, if you got any questions, don't hesitate to ask. Hey, I was cleaning up in here and I got to thinking there's a couple of things I should have pointed out before I go. You guys might be interested in these little boards on this DC side here. When you're terminating your wires, you need to make sure you keep the polarity correct. So these are polarity sensitive on this DC side here. On the AC side here, or actually the input side here, I guess, because this is AC DC. Your input side, you don't have to be concerned about correct polarity here. In fact, they don't even give you a positive negative there. So yeah, you don't have to be concerned about that there. Usually when you have a rectifier involved, this has got to be rectified. Your rectifier is ahead of your LEDs, and that's why they don't require polarization on the line side of that rectifier. Like some of these little lights I buy here, this is another light I buy from Evans Design. You can see that's actually a rectifier, and these also have a resistor built into them. This is another product I buy. I've done some of my buildings, outside lighting, goosenecks. This is a company called Evans Designs, and they're a really good company that sells a lot of specialty model train lighting for most scales. So they have a good selection of all types of lighting, building lighting, signals, and that type of thing. So that's another good company. This is kind of an expensive little light. It's like $7.50. But, I went this way, 7 to 19 volt AC DC, just so I can wire these directly to my bus, like I wire anything else on my layout, directly from my train transformers. I was thinking that, when I bought these, I thought, well, why aren't these identified? Because you would have thought these wires would be black and red. But, if you look on there, they got right there above where each one's soldered, you can see they got it marked positive, negative. So you just got to be kind of paying attention when you're wiring your wires from your power supply here to make sure you get the polarity on this match with the polarity on these. And then the other thing on this board is you can't intermix different voltage LEDs. So if you've got 3 volt LEDs and 12 volt, you can't feed them both from the same board. The instructions suggest that you either buy another one of these and put all the same equivalent voltage LEDs on the same board, or you can buy resistors and wire those in series off the board here. And that got me to thinking about, the other thing I had a concern with here as far as how much load these would hold. So, if you use a little bit of common sense here, in Ohm's law, we go back here to Ohm's law. We had 0.05 watts for one LED. If we divide that by 3 volts, that was 0.01 amps. So we know this is rated for at least 0.05 watts or 1 amp, or we can figure out what it would be if we had 3 of those on there at 12 volts using Ohm's law. So we'd have 0.005 times 3. That gives us 0.01. I ain't what I was hoping to see. Let me try this again. 0.005, or excuse me, 0.05 times 3 equals, there we go, that's better, 0.15. I knew something wasn't right. So that would be 0.15 watts for 3, and if we divide that by 12 volts, which is what I was using, we're right at that 0.01. Just so happens, I mean, it's just a sheer accident. Maybe that's why I didn't have any problems, because it's just coincident. I just stopped wiring when I got to the third LED, and so, well, that's enough to kind of figure out how many I can wire on one leg or one feeder or not. So there you go. At least I know I can get away with safely wiring 3 of these on one, and maybe more, because if I pump the voltage all the way up to the maximum on these, which is 18, then, I can squeeze some more on there, which is good to know. But I just thought I'd point that out, just to, if you had some questions about that. And, this is all about how, where to put this component. I'm looking at putting it in the building at one time, and just wire all the buildings here. But then I've got to run, in multiple directions across the layout here to do that. And then when I get done doing the scenery, I don't want to have to be dealing with that. So that's why I'm going to run just a separate feeder in here. And if push comes to shove, I will just put like this one component in a building, and then I can wire between those structures from one. And then I can also, buy a couple of more of these and put in the other buildings that are more spread out from these. And, the problem's solved. For now, I'm just going to wire off of this one and put it in my control cabinet here like I'm thinking, because, it's not going to hold me up of running the wire or having to go back and adding more wire later on. It's what this is all about. So hopefully, you found some of this useful for your own use. And I thought I'd go ahead and kick another video out this weekend, just because I didn't have much opportunity to do the first video I sent out. And since I had all this stuff out, I just thought this was experimenting myself, I just thought this would be a good opportunity to film this and then pass it on. So hopefully you can find something in this useful for yourself. And that's all I have for this weekend. And until then, you're watching Dale's Rails, and I'll see you next time. Thanks for watching.